What's the relationship have to be? Which one has to be bigger to complete that job? Yeah, your needed centripetal force has to be bigger than the gravitational force, or at least equal to it. Okay, so you just have to remember, oh, my centripetal force is greater than or equal to Fg. So as long as this is bigger, hey, that's gravy. Yes.
What about like calculating going into the X when you want?
Oh yeah, I mean, like I'm going to give you like a lemming problem. Like here you're at 30 degrees, and you're going to have to find the X and Y components of it. Oh, I promise you, yes.
I don't know.
It's trig functions. I'm going to give you this. So let's say that's 20 meters per second, right? So what's the first thing that you're going to do?
Right stroke of code.
Not smile, James.
I was gonna say, after we smile. Well, we've already smiled. This is probably.
This is way post smile.
Yeah.
Okay. So here's this angle. How do you find the side opposite? What are you going to use? Sine. What are you going to use to find adjacent? Cosine. Okay? So this is, I don't know, I'm just going to make this up. Let's say that's 10 meters per second. And that's going to be 18.2. I don't know what it is. I'm just going to make up a number. Now, as this thing flies through the air, okay, if you have an initial vertical velocity of 10 meters per second, okay, an initial vertical velocity of 10 meters per second, I want you all to think very carefully before you answer this question. Okay, right here. Right? Roughly, how long is that thing going to take to reach maximum height? At this point, none of you should have to give any hesitation, and you should go, wow, I got this.
Roughly 1 second?
Roughly 1 second. Now, Mr. Johnson, you were the first one to hold up the 1. Why?
Because with the acceleration of gravity, it's 9.8, and that's 10. So
Yeah.
it'll take about a second.
Yeah, so, but yeah.
Yeah.
Ooh, fourth down, okay.
There
It's
we
on
go.
video.
Oh, we got it on video.
So, that's going to get edited.
No, it is not.
No, it's not.
You are far too lazy for
Oh,
that.
that makes it.
Who said that?
Everyone.
President.
You think I'm too lazy to go through and edit
Are
that
you
little bit
going
out?
to? Well, now
Please
you're
don't.
getting
We're not
down
doing
to
that.
this.
Please don't.
Oh, I hope it makes the final cut.
Okay, so, oh, it's a hard one.
Why'd you make it?
Well, if I'm going to force that, I might as well draw a heart too. That's a jack up everybody. Okay,
I'm gonna pass this test tomorrow. I
So,
have video, so you can't force
you got a 10 meter per second, right? So acceleration due to gravity is about 10, okay? If the mass of the Earth was a little bit bigger, or we were a little bit smaller, we could round up and we could call it 10. All the math calculations would be a lot simpler. So it's going to take about a second to go up. So it's going to take about
Second to go down.
a second to go back down. Okay?
Nice, James.
Nice, James. And that's assuming that it's symmetrical. Okay? What's going to happen to your Vx component?
Gonna stay the same
It's going to stay the same. Why?
because there's nothing acting against it.
Yeah, for lack of a force, the velocity stays
Constant.
constant. Okay? Now, if I launch this on top of a hill, like this, what type of energy does it have up here?
Potential.
And kinetic.
No,
Okay?
it was launched yet.
Yeah, it's launched. Okay?
Once it's
It's on now. It's launched. So, once it's launched, it has kinetic and potential. When it lands down here, it only has kinetic. Now, that was launched at 10 meters per second at an angle of 30 degrees. What if I take that and I go, you know, I'm just going to shoot it out horizontally at 10 meters per second? What's that going to do to the speed that it has when it lands?
Nothing.
Nothing. It's still going to be the exact same speed. Why?
It's like that question.
You still have the same kinetic energy? Does it have the same UG?
Yeah.
Yes, guess what? It's going to have the same kinetic energy out here. What if I launch it straight down at 10 meters per second? It's going to land with the exact same speed. Okay? If I shoot it straight up and have it fall, it's going to land with the same speed. Okay? Is the angle going to be completely different? Yeah. Are your X and Y components going to be completely different? But the overall speed is going to be the same. Moses?
Will there be a barbecue roll?
Okay, that was evil.
Yeah.
I don't know.
The satellite.
If I do, it won't be like the whole big. If I do, Moses, If I do, I won't make you do all the calculations to get the acceleration, okay?
To us.
Right? But now, let's talk the barbecue roll.
Wait, Eric, before you go to that, can you do, like, one of the problems, that's a living problem and it has to clear the wall? Will we have?
I won't give you anything like that. But, so now, when something spins, okay, what's the one thing that you cannot use in any way, shape, or form when you're trying to make something spin? F equals ma. You cannot use F equals ma. But you can use the idea that torque equals two things. What does torque equal? Force times radius, and it equals
I fish.
high fish. Okay? So what I might do is say, hey, this needs an angular acceleration of 5 radians per second squared. Okay? Here's the moment of inertia. Here's the radius, how much force is needed. Okay? I might give, if I ask you to do this, I will give you a lot of these numbers. Okay?
We're gonna do a barrel one?
Bub in a
Yeah,
barrel?
in a barrel.
No.
Yeah.
Okay?
What
Now
are we
again,
gonna
are you going to have to know what centrifugal motion is? Are you going to have to know the direction of the centrifugal force? Yes? Okay? You're going to have to know all that. Okay, so here's what you're going to get for the review. You're going to get a page that's going to have all the topics that you need. Okay? Then you're also going to have a then one page with 36 questions on it. Okay? For the review itself. And then you're going to have all the solutions worked out for the review. Now, if you go through and you know how to do something, don't worry about it. Skip it. Okay? Don't work stuff that you already know how to do. This is what I would do if I were you all. I'd go through the problems. Well, actually, I'd look through the topics first. And then I'd highlight any things like, ooh, iffy on that, never quite understood that. Okay? Then I'd go through and I'd read all the problems. And as soon as you come across a problem that you know, wow, I have no idea how to do that problem, highlight those. Work those problems first. Especially if you go through here and if I said rubber stopper swing in a horizontal circle, period is 10 rotations, 23 seconds, determine the tension and the strength. If you got that and you're going, oh, I got nothing on that. Okay? Work the problems first that you don't know how to do. Then go back and pick the low-hanging fruit. Okay? Got it? Okay, so stop that. I will hand out everything.